All right, so here's the second half of your review video. We're going to start with 18 and we're going to go through the end. All right, so number 18, what is the solution of the equation? All right, so the first thing you want to do when you have a radical like this is you want to isolate the radical. So we want to get this square root here by itself. So we're going to add the 6 to the other side. So we're going to get the square root of 2x plus 8 equals 6 minus 4, which is 2. And now since we have the square root of something, we're going to take and square both sides so we can get rid of that square root. So this is going to be 2x plus 8 equals 2 squared, which is 4. Now it's just a simple solve for x. Subtract 8, subtract 8. 2x equals negative 4. Divide by 2, so x equals negative 2. All right, so for 18, the answer is B, negative 2. Number 19, you do it the same way. We're going to subtract the 3. All right, so that gives us 2, the fifth root of x plus 3, I'm sorry, 6, x plus 6 cubed equals 19 minus 3, which is 16. Now we're going to divide off the 2 to get rid of the 2 in front. So now we're going to have the fifth root of x plus 6 cubed equaling 16 divided by 2, which is 8. Now, to get rid of the fifth root here, we're going to have to raise both sides to the fifth power. So, fifth power, the fifth root cancels out with the fifth. So we have x plus 6 cubed equals 8 to the fifth, which is 32,768. Now, since this x plus 6 is cubed, in order to get rid of the cube, we're going to take the cube root of both sides. Because the cube root will cancel the cube, leaving you with x plus 6. And then the cubed root of the 32,000 comes out to equal 32. And then just subtract the 6 across. So x equals 26. So for 19, your answer is A. All right, for 19, your answer is A. All right, let me clean this up to do number 20. All right, for number 20, we're still going to isolate the parentheses. All right, so let's get the parentheses isolated. So plus 5, plus 5. So we're going to have 4 times 3 minus x to the 4 thirds equaling 64. We're going to divide both sides. That's supposed to be 4. Going to divide both sides by 4. That'll get rid of that. Now this here, this 3 in the denominator means you have a cube root. And then you have 3 minus x. And then this 4 in the numerator here means that the parentheses are raised to the fourth power. And then, of course, 64 divided by 4 is 16. All right, so now to get rid of the cube root, we're going to cube both sides. So we're going to get 3 minus x to the fourth equals 16 cubed, which is 4,096. And now, since the parentheses here is raised to the fourth power, we are going to take the fourth root of both sides. So we're going to have 3 minus x equals the fourth root of 4,096, which is 8. Now, don't forget, since it's a even-powered root, we don't have just 8, we have positive and negative 8. All right, so now let's subtract the 3. So now negative x equals negative 8 minus 3 is negative 11, and then positive 8 minus 3 is 5, but we have a negative x here, so let's multiply everything by negative 1 to make the x positive. So x is going to equal negative 5 and positive 11. So it looks like the answer is A, negative 5 and positive 11. Don't forget, when you're dealing with numbers and you take an even-powered root of a number, you have the positive and the negative of that number. All right. Number 21. All right, if we notice here, both sides are raised to the 1/5 exponent. Well, since we have a fraction, we know we're going to have a radical. And since we have a 1 for both numerators, we know that this is just simply going to be the 5th root because the denominators are 5. So both of these are the 5th root of their corresponding terms. Well, if it's a 5th root, what are you going to do? You're going to raise both sides to the 5th power. Because remember, when you raise an exponent to exponent, you multiply them. So 1/5 times 5 becomes 5 over 5, which is just 1. And the same thing over here. So basically, the 1/5 and the 5 will cancel themselves out, leaving us with 2x plus 6 equals -8 plus 10x. Now it's just a simple solve for x. Add the 8 to over here. Add the 2x, to over here. So we're going to have 12x equals 14. Divide off the 12. So we get x equals, we can pull a 2 out of both of these to get 7 over 6. All right, so it looks like 21. The answer is also A. All right. So again, when you have just like an exponent like this one, we had the term raised to 1/5. Just simply raise the entire term to the 5th power, and then the 1/5 and the 5 will cancel out, leaving you just the term. So in this case, just the 2x plus 6 and just the -8 plus 10x. All right. Number 22, we're skipping, and no, it won't be on the test, so don't worry about 22. Let's go ahead and go on to 23. We want to find f minus g of x. Well, this is f of x, and this is g of x, so it's going to be as simple as it sounds. We're going to do f of x minus, don't forget to put g of x in parentheses. Why? Because this negative sign will get distributed through. So we have 4x minus 5 minus 6x minus 3. I don't know why I wrote 13. So now we have 4 minus 6x. Well, that is a -2x. And then -5 minus 3 is -8. All right, so f of x minus g of x is, I'm sorry, that's a plus. Oops. That's a plus 3. So because negative times -3 is +3, so -5 plus 3 is -2. All right, so f of x minus g of x comes out to -2x minus 2. The only thing is make sure when you're subtracting, you put the second function in parentheses because that negative sign will get distributed through the entire equation. All right. Number 24. We want to find f of g of x, because remember that's an open circle, so that means it's a composition function, so we're going to evaluate f at g, and we're not just going to multiply them together. So remember, you always take the second function and substitute it into the first function wherever you see an x. So f of g of x, we'll get to the -5 part later, is simply going to be -2 parentheses minus 4x plus 3 and then -7. Distribute this through. We're going to get 8x minus 6 minus 7. So we're going to get 8x minus 13. That is going to be f of g of x. All right. Now, the only thing you do differently for this -5 now is you're going to have f of g of -5. The only thing you're going to do differently is take this -5 and substitute it in for x. So we're going to have 8 times -5 minus 13. Well, that's -40 minus 13. So that is -53. So the answer for number 24 is B, -53. All right. Make sure you keep up there with your positives and your negatives and don't get them mixed up or lose any of them or anything like that. All right, now let's go to 25. 25 works similar to number 24, except now we're just going backwards. Now we're taking and evaluating g at f. So we're going to take the function f and plug it in for all the x's in function g. So we're going to have g of f of x is simply going to be x plus 2 squared, quantity squared. All right, now we can go from here two different ways, the easy way and the hard way. The hard way would be to go ahead and square out the x plus 2. You'd get x squared plus 4x plus 4. Then you would go in for all those x's and put in the negative 5. Or we can go ahead and put in the negative 5 now. So just put in the negative 5 for x. So we're going to get negative 5 plus 2 quantity squared. Well, negative 5 plus 2 is negative 3. Quantity squared is 9. All right, so for 25, your answer is going to be positive 9. So when you have a case like this, you don't have to square out the x plus 2. All right, all you have to do is put in the negative 5. Negative 5 plus 2 is negative 3. Negative 3 squared is 9. It's simple. All right, don't worry about trying to square it out and making the problem harder than it needs to be. All right, number 26. We're moving right along. What is the inverse of the given relation? All right, so remember, when you go to find the inverse, you switch the x's and the y's. So this is going to be x equals 7y squared minus 3. All right, and now we have to solve for y again. So plus 3 plus 3. So x plus 3 equals 7y squared. Divide by 7. So y squared equals x plus 3 over 7. Since this is y squared, we want to take the square root. So y is going to equal plus or minus the square root of x plus 3 all divided by 7. All right, so the answer is going to be A. For number 27, we also need to find the inverse. So go ahead and switch x and y. To get x equals 3y plus 9, subtract the 9. So 3y equals x minus 9. Then go ahead and divide off the 3. So y equals 1/3 x minus 3. So it looks like a letter D. All right. Now, if you're wondering what exactly I did there, I just split that up into two fractions is all I did. All right. X over 3 is x divided by 3, or simply 1/3 times x. And then the minus 9 divided by 3 is simply negative 3. All right, to see it written out, I did x over 3 minus 9 over 3. That's your 1/3 x, and then of course that's your negative 3. All right. Let's go to number 26. Graph the function y equals negative 4x squared minus 2 and its inverse. All right, so let's see how this graph is transformed. All right, this negative sign here turns it over, so that means it opens down. So it can't be A and it can't be C because neither of those open down, so we have it narrowed down to B and D. The 4 stretches it. Well, if you look, they both look stretched. But this negative 2 makes the function go down 2 units. All right, so let's scroll down a little bit here so we can see the graphs now, because we know it's one of these two. All right, we know it's B or D, because we know it opens down. Now, all we have to do is figure out which function or which one of these graphs reflects over the line y equals x. So if we were to physically take this and fold it over the line y equals x, would these two match up, or would these two match up? All right, think about it for a second. If you were to physically take this and fold it over this line, all right, which ones would match up? Letter B would definitely match up, because when you folded this over, this point would become up here, and then this point here would come over, as well as this point here would come over. Okay, this one here, I don't know what they were trying to go with, but it's not going to work. All right, so the answer here is B, because this one you can clearly see reflects over the line y equals x. All right, moving on. We're almost done here. 29. For the function f of x equals the square root of x minus 5, find the inverse and the range of the inverse. So let's first start off by finding the inverse. So we have y equals the square root of x minus 5. Switch x and y. So we have x equals the square root of y minus 5. So the first thing we want to do is square both sides. So that cancels that. So we have x squared equals y minus 5. Add the 5. So our inverse of f of x is going to equal x squared plus 5. So that rules out a and b because those are x squared plus 25. All right, so that rules out a and b. Now we want to find the range for the inverse. Well, the range for the inverse is simply the same as the domain for the original function. All right, and what is our restriction on our original function? Well, if you look, we have a square root there. And remember, you can't take the square root of a negative number. So the x minus 5, which is your radicand, has to be greater than or equal to 0. All right, so the x minus 5 will have to be greater than or equal to 0. Well, to get the domain, all you do is you just solve this inequality. Plus 5, plus 5. So x is greater than or equal to 5. All right, now, the only thing you change about it when you take it to the range of your inverse, because remember the domain of the function is the range of the inverse, the range of the function is the domain of the inverse. The only thing you have to take into account is the range always goes with your y values, and the domain always goes with your x values. So this is x is greater than or equal to 5. When you bring it to your range, it's just going to be y is greater than or equal to 5. All right, so the answer here is D. Your function, your inverse is x squared plus 5, and then your range is y is greater than or equal to 5. All right. Number 30. I'm going to show you two different ways to do this one as well. I'm going to show you the long way first, then I'm going to show you the easy way. All right, so we want to take the inverse and evaluate it at the actual function. So the first thing we need to do here is get the inverse. So we have y equals 14 over x plus 3. So flip x and y, so I'm just going to erase them. All right, so I'm just going to erase them. So now, all right, so now we're going to have x equals 14 over y plus 3. Now we just have to solve. So I'm going to multiply both sides by y plus 3. That'll get it out of the bottom here. So we're going to have y plus 3 times x equals 14. Of course, we want to get the y by itself, so we need to go ahead and divide off the x. So now we have y plus 3 equals 14 over x. Subtract the 3, subtract the 3. So y equals 14 over x, and then minus 3. So this is our inverse. Okay, 14 over x minus 3. So now that we have our inverse, we're going to take our original function, plug it in for the x on our inverse, and then solve it out. So that should have been a g because this is g's, so that should have been a g as well, but it doesn't really matter. All right, so we want g of the inverse evaluated at g, and we're going to do x. Always always put an x here first. All that means is you're just getting your function, you're not evaluating it anything. After we get our function simplified all the way down, then we're going to go back and plug in 4 for all the x's. All right, so this is going to be 14 divided by 14 over x plus 3. Then, of course, minus 3 because we had to bring this one down. Now, we don't actually divide by a fraction. All right? We don't actually divide by a fraction. What you do is, remember, you keep the first one, so you keep this 14, change this to multiplication, and then you take the inverse or the reciprocal of this. So x plus 3 over 14, and then, of course, the minus 3. These 14s will cancel out because this is technically 14 over 1, so you have a 14 in the top, 14 in the bottom, they cancel out. So we're left with x plus 3 minus 3, the two 3's will cancel, leaving us with x. So g of the inverse of g of x simply equals x. So now if we want g of the inverse of g of 4, you simply plug in 4 for all the x's, so you just get 4. Okay, so the answer here is C. So that's the long way to do it. The short way to do it is this. If you remember the rule that f of the inverse of x will always, always, always equal x, and the same thing is true the other direction, the inverse of f evaluated at f of x, if they're true inverses of each other, they will always, 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 always equal x. So if I ask you to find the inverse evaluated at the original function of 4, it's just going to be 4. Because remember, this here just comes out to x, and then you're just subbing in 4 for all the x's, so you're just going to get 4. Okay? So anytime you see the inverse evaluated at the original function, or the function evaluated at its inverse, it's always going to equal x. And if you happen to have a number after it, like in this case we have the 4, then this function right here is always, 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 always going to equal 4. There's no way it could ever equal something else. It is always, always, always going to equal 4. All right? Let's go to 31. Graph the equation. Square root of x plus 1. Well, the good news is we've already gone over transformations, and we know what the y equals square root of x looks like. We know it looks like this. And of course, this plus 1 just simply moves it up 1 unit. So has this moved up 1 unit? Well, yeah, it has. So 31 is A. This one here, this would be a negative. You'd have to have negative square root of x. That one's not going to work. This one, again, you'd have to have a negative square root. That's not going to work. And this one has been moved down 1, so that one doesn't work either. All right. Moving along, the last problem. This video is probably getting pretty long. Yep, it's already 23 minutes, but we've only got one left, so let's go ahead and knock it out, and we will be finished with this. All right, so again, we have our parent function is y equals square root of x. So again, we know it looks like this. And of course, this negative 3, since it's inside the parentheses with x, all right, since it's inside the parentheses with x, that means it moves it left or right. And since it's a minus, that means it moves it to the right 3 units. So we know it's going to go upwards, so we know we can't have C or B. And then this one, and then A has been moved to the right 3 units, whereas D has been moved to the left 3 units. So the answer for number 32 is also A. Okay? So hopefully that has clarified some of this exam review. Feel free to watch this video as many times as you need to, and make sure you're ready for the test. See you tomorrow.